Okay, so we're back. It's week 4. This is lecture 7, and I just finished up covering, reviewing the week 1. I'm going to move on into week 2 now. Okay, so the text states that vegetable oils have 10% less heating value than do diesel because of the oxygen in the, and actually I think to be more correct, there's no reason to put O2. I think O2, just kind of, you read that as oxygen, but just O, additional oxygen in the vegetable oil molecules. Given the data in the text for vegetable oils, calculate the higher heating value of petrodiesel. And again, the higher heating value is the value, assuming that you recover the thermal value from any combustion products that result, that you're not simply exhausting those combustion products of the atmosphere, but you're allowing them to recondense. So let's go ahead and take a look at the solution. Here's the week 2 solution. Okay. So yeah, this is very similar to what we were working in class before. So the higher heating value is in the order of 38.5 megajoules per kilogram for vegetable oils. And to calculate the diesel HHV, we're simply adding another 10%. I don't know why. Well, he's written this in as one. Well, the way this should just be written is simply, that's a little wonky. Let's just write it out like this. 39.5. I think that should just read times. Well, another way to look at it is multiplied by 110%. So 39.5 times 1.1 equals 43.45, thereabouts. So coming up with an answer on that order is correct. Then we're just going to convert megajoules per kilogram. There are 947 BTUs per megajoule, and there is 1 kilogram for 2.2 pounds. So just running it through that, we end up with 18,909 BTUs per pound. And let's just take a look at this like online conversion. Angles, acceleration, there's energy. I remember this website, this is fun. Okay, so B2Us to megajoule. Convert. There you go. So 1 BTU is 1/1000th of a megajoule. If we run it the other way, it's usually easier just to run it the other way. Usually easier to work with numbers bigger than 1 rather than less than 1. So if we go megajoules to BTUs, there we go. 1 megajoule is 947.8 BTUs. All right, so there's the week 2 homework. The week 2 quiz, I just want to make sure everybody's up to speed on that. Okay, that's great. 6 attempts. Let's just take a quick look at it. Let's show the report. There's a neat little way to, actually, I'm going to pause it one more quick second here. All right, so this is the data that I'm looking for. So the quiz had 11 questions. And what this is showing is that the intended weight of the question, each of the questions was weighted the same, 9.9%. The effective weight, so if I come through here, I can take this data, and if I parse it out like this, let's center it so it's a little easier to read. And if I take this data and sort it, and my data has headers, if I sort it by the effective weight, it looks like these questions had more weight because they were the ones that were missed more frequently.
I still can't find anything to label C10 numbers, and I read it twice. Do I go with someone else for that?
You know, I was having trouble finding the definition of cetane in the book too. Was that what your issue was, finding it in the book? Yeah, let's look at the cetane question. That's one that's been bugging me as well.
It's not only finding it, it's finding specific values, like, I know it's bigger than diesel, but what is the diesel value?
Mm-hmm.
I was thinking that might have been a table that I missed through, so I looked through it again, I still couldn't get it.
Yeah, I was having trouble finding that too. Let's just go and look at the cetane.
Cetane number of oil, vegetable oils range from 25 to 60, that's false, isn't it?
Well, let's plug that in and see what we get.
Got one right.
I did. Well, it's the only one I attempted. So the cetane number of vegetable oils is in the range of 25 to 65 centistokes. Let's just go and look up cetane.
Jump right to the wiki page.
Let's hit it. So it's a measure of the combustion speed. I think what's confusing about the question is that I don't think its units are in stokes.
Stokes. Getting all stoked with some centi-stokes.
No.
Gotta use a lot of centi-stokes to get one stoke, right?
I think 100 of them.
10, 100, gotta use 100 centi-stokes to get one stoke.
So here we go.
God, that's a
Yeah,
market stoke nightmare.
well, I think that's really all it comes down to is that the cetane number is not measured in centistokes. Centistokes is a measure of viscosity, not cetane number.
But what is the cetane number
Oh,
for vegetable oil? That is my specific question.
42 to 46 to 52. So I think
That's
this.
not in the book.
No, it might not be. I think this question is false on two different fronts. The range is too large, 25 is too low. Although, I'm sure you could make one that's that low. Let's just take a look here. Pause the recording for a quick sec. See what's in the book. So we just went into the book, and there is a table 2.5, the cetane number is for pyrolysis oil in comparison to diesel and biodiesel. We're looking at cetane numbers of 40 to 47. There's also a long list of cetane numbers in table 2.4 on page 27. So cottonseed is 33. Yeah, the cetane number is dimensionless. So this question is false on two different fronts. Cetane number is not measured in centistokes. That's what viscosity is measured in. And the range, I'm looking at linseed oil, and it's 27.6. So the range is actually not that far off. The low end is lower than the lowest value on 2.4, and the high end is higher. But the thing that's wrong is that the cetane number is not measured in centistokes. All right, I think we're caught up on week 2.
Dirty professor question.